Hi, good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, we are going to discuss about basic RL circuits. This topic comes under the Unit 3. There is a transient and resonance in RLC circuits. Come, let's get into the topic. So, what is actually a RL circuit? We know what is R and what is L. That is resistor and inductor. So this circuit or network or a filter is a type of circuit having a combination of inductor and resistor and is usually driven by some power source. As such, an RL circuit has the inductor and the resistor connected in either parallel or series combination with each other. So they are either driven by current, that is the parallel, or a voltage, that is series source. Besides the resistor or inductor L and capacitor C form the basic passive linear circuit element. They can form an electrical circuit in four different ways, like the RLC circuit and RFC circuit. Alternatively, an RL circuit is also described as an electric circuit with resistance and self-inductance. We already know that the process of induction occurs when an EMF source is applied by continuous change in the magnetic flux. The mutual inductance is an effect of loss of induction presented by Faraday, while self-inductance is an effect of loss of induction of Faraday of a device coming on itself. So, the inductor is a circuit or a device component that exhibits self-inductance. However, since there is a presence of resistor in the ideal form of the circuit, an RL circuit will consume energy akin to an RC circuit or RLC circuit. So, you can see this is the RL circuit. We have one voltage source, one AC voltage source, V of T, and seriously one resistance is connected, and again followed by the resistance one inductor is connected. So the voltage across the R is VR and the voltage across L is VL. So the current flowing through this loop is called I of T. So consider the above circuit diagram having a battery, a resistor, and a switch. The switch can either have either have the battery in the series connection to the circuit, or the battery can be removed from the circuit. When the switch is closed, the current jumps to the maximum value, and when the switch is opened, the value of the current decreases immediately. When an inductor is added in the series with the resistor of the circuit, we come to observe changes in the current. So the role of an inductor in the circuit is to oppose the change in the magnetic flux. It is the inductor does not allow the spontaneous change in the current. When we close the switch of the circuit, there is a gradual increase in the value of current to a maximum value. When we open the switch and remove the battery, the inductor voltage causes the current to reduce gradually to the value of 0 again. The first order RL circuit mainly comprises one resistor and one inductor to form a RL circuit. The power factor of the circuit is low because of the inductive load and the phasor induction motor. So even the lamps, transformers, welding devices operate at low lagging power factors. In RL series circuit, the flow of current is lagging behind the voltage through an angle, that is pi, due to the inductor effect. So here the power factor can be given like the cosine of lagging angle pi. So the power factor cos pi equal to resistance by impedance, which is equal to R by Z. A circuit that contains a resistance R connected in a series with the coil having an inductance L is known as a RL series circuit. When a supply voltage V is applied across the current element I flowing in the circuit, IL and IR, the current flowing in the inductor and the resistor, but the current flowing across both the element are the same as they are said to be connected in the series connection with each other. So here this VL, this we already know. VR is a voltage across resistor, and VL is the voltage across inductor, and VT is the total voltage across the circuit. So in the above simple RL series circuit, where the resistor R and the inductor L are combined in series combination with voltage source having V voltage. So the current flowing in the whole circuit is I amps, and the current through the resistor and the inductor is IR and IL. Since both the resistance as well as the inductor are connected in the series combination, the current in the both of the elements of the circuit remains the same. Here IL equal to IR equal to I. So because current will be same. IL current, the current through the inductor and the current through the resistor, both are equal, so it is called as I. So the final the equation across voltage across the RL circuit is V of t equal to VR plus V. So parallel circuit, the parallel RL circuit is generally of less interest than the series circuit. It can be interesting until it is fed by the current source. This is case with the parallel RL circuit mainly because the output voltage Vout is equal to the input voltage Vn. As a result, this circuit does not act as a filter for a voltage input signal. With a complex impedance IR equal to V impedance by R, that is IL equal to V impedance by J omega L, which is equal to J V I impedance by omega L. So this is the parallel circuit where R and L are connected in the parallel. So this where we are using means in chokes of luminescent tubes, that is fluorescent lamps, and for DC power supply to the radio frequency amplifier and the radio transmitters, and resonant LC and RHS circuit communication systems, processing of signals, oscillator circuits, magnification of current or voltage, variable tune circuits, and filtering circuits. So these are the applications of RL circuits. Thank you.